Welcome to one of the simplest topics in quantitative methods, and this topic is on descriptive statistics. Descriptive statistics and regression are the easiest topics in quantitative methods. And so this is a build-up from our grade 12. So if you pass through grade 12, at least this will be a reminder of what you already know. So when you're dealing with descriptive statistics, we are mainly looking at grouped data and ungrouped data. So I'll teach this in two classes. I'll start with the basic components of descriptive statistics. When data is arrayed like this, it's not arranged in clusters or in groups, it's called ungrouped data. Ungrouped data. So this is a sample from which we're going to draw what is called a sample mean, sample standard deviation, and the variance. And when data is grouped like this, it is called grouped data. Now, before we go into the formulas of computing each of these ones here, we need to understand what are called pictograms. And this one here, I'll ask you to participate. Can you remember what is pictogram A? Anyone? What is A? What is B? What is C? At least we need to understand where we're coming from. What is pictogram A? Caroline, George, please speak on any of the pictograms that you think you know. Quickly, what is A? What is A? A is a pie chart. B is a bar chart. C, what is C?
The
Yes, calling.
histogram.
Yes,
Histogram.
the histogram. Then what is D? The line that cuts the midpoint is called an ogive. E is a cumulative frequency graph. E is a cumulative frequency graph. And F is a what? A relative frequency graph. The relative frequency falls down. And these are different forms of bar charts. These are different forms of bar charts. All right, so now we get straight to business. Whenever you're given ungrouped data, we first arrange it in order of ascending from the smallest to the biggest. 1, 2, 3, 4, 5, 6, 7. We have 7 data sets that have been arranged from the smallest to the biggest. When you square them, 2 times 2 is 4. 4 times 4 is 9. 3 times 2 is 9. 4 times 4 is 16. 8 times 8 is 64. And we total them up. This is called the summation of x, which is 38. This is summation of x squared, which is 242. So they are what we call measures of central tendency and measures of dispersion. So we start with the measures of dispersion. So we now want to understand what is the range. A range is simply the difference between the highest number and the smallest number. So this is 8 minus 2, which is giving us what? A 6. That is our range. When we divide the range by 2, we call that the mid-range. The mid-range. The median is simply the middle value. We have added all these figures. Our sample size n is 7. So to find the median is simply the middle value. You can manually do this by crossing out, crossing out, crossing out, crossing out until you find yourself with the middle value, which is 6. But using the formula, it's simply n plus 1 divided by 2. 7 plus 1 is 8. You divide by 2, it is 4. So 4 is not the answer, but the position. You count 1, 2, 3, 4. On position number 4, our median is 6. In the event that our n is an even number, for instance, we have 10. So n plus 1 divided by 2. N plus 1 divided by 2. So 10 plus 1 is 11. 11 divided by 2 is 5.5. What does 5.5 mean? You count the 5th number and the 60th number. You divide by 2. The 5th position and the 60th position divided by 2. If you're at 7.5, you start with 7, and the next number, which is 8, divided by 2. That is how we find our median. Then when we're going to the mode is simply the most frequent number. Which number appears the most? Which number appears the most here? The highest frequency here is what? 8. So 8 is our model value. 8 is our model value. So the number appearing the most is 8. Sometimes you have 2 3s and 2 8s. This is called a bimodal frequency. Yeah, it's possible to have more than one most appearing value. Then we get what we call the quartiles, what we call the lower quartile and the upper quartile. Our formula still goes back to what? N plus 1. So if you're dealing with a lower quartile, it's a quarter. It's a lower quarter, it's a quarter of n plus 1. So Q1 is a lower quartile, which is given by n plus 1. We just do a quarter of n plus 1. That is the first quartile or the lower quartile. The second quartile is your median, which is Q2. So our Q2 is 2 over 4, which is the same as half of n plus 1. Our second quartile is simply half of n plus 1. And finally, our upper quartile is 3/4 of n plus 1. So you need to know Q1 is a quarter, Q2 is half, and Q3 is 3/4. So it's called the upper quartile or the third quartile. So since our n was 7, 7 plus 1 is 8. A quarter of 8 is 2. So we look for the second number. A quarter of 8 is 2. So we look for the second number. So when you go here, a quarter of 8 is 2. So position number 2, we go here 1, 2. So 3 is our lower quartile. Our upper quartile is 3/4 of n plus 1. So 3/4 of 7 is 6. So you count 1, 2, 3, 4, 5, 6. So the third quartile is 8. Our 8 is the third quartile. So lower quartile, 3. Interquartile or the second quartile, 6. And the upper quartile is the 6th number, which is 8. Now the difference between the upper quartile or the third quartile and the first quartile is called the interquartile range. Q3 minus Q1 is also called the quartile deviation. So 8 minus 3 is 5. Anything half is called the semi. So the half of the quartile deviation is called the semi-quartile deviation. So half of 5 will give us a 2.5. This is called our interquartile range. So these are the measures of dispersion. Then we already found the totals. Summation of x squared is 242, summation of x is 38, and summation of, and our n is 7. For a sample mean, the sum simple is given by x bar. So summation of x over n is the formula for the mean. So in this case, 38 over 7, we get 5.43. So this is how we find our mean. We find the variance, it's the sleeping 6 here. This is called sigma. So we have summation of x squared minus summation of x to the power 2 over n, everything over n minus 1. Here you need to be diligent when you're doing the substitution. So the formula for the variance is given by sleeping 6 here. This is for population variance. For example, variance is just s to the power 2. It is given by summation. This e is called summation. So summation of x squared minus summation to the power 2 over n, everything over n minus 1. People have a problem with substituting just these simple things. You need to be extra careful. Summation of x squared is a bigger value. All right. So we substitute as follows. So I want you to try to substitute. Let me see whether you're okay with substitution. Summation of x, suppose that is 10. Summation of x squared, maybe that is 100. And our n is 5. I want you to try to substitute that. I've given you all the parameters. Kindly try to substitute that. Who wants to lead us? So here we're going to have what? 100 over what? 5. Everything divided by what? 5 minus 1. What are you getting? Please calculate that. What are you getting? 100 minus what? 20 over what? 4.
4.
What is your final answer? 20, isn't it? 80 divided by 4 is 20. All right. So you get 20. And the standard deviation is simply the square root of what? The variance.
Variance.
So square root of 20, which is what you can get. I just wanted you to get the gist on how to substitute. Otherwise, those figures were just arbitrary. I usually have problems with students in substituting this. So here in the actual figure here, our variance is 5.952. Then when you square root it, you get 2.44. So the relationship between the variance and the standard deviation is that when you square root the variance, we get the standard deviation. Is that clear? Okay. Then when we go to the coefficient of variation, it's simply the standard deviation over the mean times 100. So we found our standard deviation as 2.44 and our mean as 5.43. So when you divide these times 100, you get 44.94%. So that is how we find our what? Our coefficient of variation. Coefficient of skewness is simply 3 x bar minus median over standard deviation. 3 x bar minus median over standard deviation. So our x bar was already calculated. Our x bar was already calculated as 5.4. Our median was 6, and our standard deviation is 2.44. So what we are getting is 0.7. Now the significance of the coefficient of skewness is it tells you where chaffing where are we biased to. If you get a negative, it means you are skewed to the left. If you get a positive, it means you are skewed to the what? To the right. That is all you need to know. So the skewness also can tell you in a class if the skewness that you're getting is a negative, it means the majority of people failed. It means the majority of people failed. If you get a positive, it means the majority of people passed. So the coefficient of skewness simply gives you a picture of increase of finina. So this is how we look at ungrouped data. So these are the small things that people get to what? To mess up. So this is on ungrouped data. Any questions on ungrouped data? I'll talk about Chebyshev's rule in the next class, but here I just want to start with the most basic. I'll give you homework based on what we have discussed today. I require this before our next class. I need you to be as interactive as possible. Okay, so I told you that when we are dealing with grouped data, information will be classified. You'll be given class with 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and the frequencies here as 1, 3, 7, 5, and 2. Now, the first thing you need to do is to come up with what is called the cumulative frequency. We'll put our 1 here. Then you add 1 plus 3, 4. You keep adding 4 plus 7, 11. 11 plus 5, 16. 16 plus 2 is 18. This 18 must always be the same as the total of the frequency here. So summation of f is 18. This is also same as n. Summation of f is simply the sample size that we have here, 18. Now in the class, this is called the lower bound denoted by L, and the numbers on the right are called the upper bound denoted by U. This is how we deal with this. This is called the distribution table. This is called the distribution table. Now, X is called the midpoint. It is found by adding the lower bound plus upper bound divided by 2. 1 plus 5 is 6, divided by 2 is 3. 6 plus 10 is 16, divided by 2 is 8. 11 plus 15, 26 divided by 2 is 23, and so on and so forth. So this is how we find this column, which is called the midpoint column. Midpoint column. So if you want to find the height, you just find the differences in the lower bounds only or the upper bounds only. 6 minus 1 is 5, 11 minus 1 is 5, so the height is 5. Don't subtract these two because this is not an adjusted class. So if you do subtract 5 minus 1, you get 4, which is not the height. You're better off subtracting this bound here, 5 minus 5 from 10. So you're going to get a consistent 5, 5 this side, and a consistent 5, 5 the other side. Now, I said the midpoint is simply the lower bound plus upper bound you divide by 2. Alternatively, if you find the first midpoint, 1 plus 5, 6 divided by 2 is 3. You can continue adding the height to each of these ones. You get, so you have 3 plus 5, 8, 8 plus 5, 13, 13 plus 5, 18, 18 plus 5, 23. So this midpoint also gives you the height. It's consistent. The distance between these two values is the same as the distance between these values and these values. So in an exam, you can only find the first one and just add the height throughout. X squared, you're just squaring. 3 squared is 9. 8 squared is 64. 13 squared is 169. 18 squared is 324. 23 squared is 529. So we don't need the totals if it doesn't have an F. We only need the totals where there's an F. So F times X. Multiply this F times the X column. So this is 3. This is 3 times 8, which is 24. 7 times 13, which is 91, until the end there. That's how you guys find 254. Then fx squared, again you start from f and x squared. So 1 times 9, 9. 3 times 64, 192. Then 7 times 169, you get 1183. Never make a mistake of squaring this one. 3 squared, 24 squared, this is a mistake they make. That's why I put a dot there. You start from here. So this column times that one gives you fx. This column times that one gives you f dot x squared. Never square this to get this answer. You cannot risk losing marks. These are the common mistakes most of your colleagues make. So since there's an f here, we can total here. This is an f here, there's a total there. So the question is, how do we find the mean, standard deviation, variance for group data? Likewise, the formulas are the same except that we have an F only. Before I go there, there's what we call the relative frequency and the relative cumulative frequency. Relative means subject to the total. So for the relative frequency, you just get out of the total. So 1 out of 18, which is this one here, 3 out of 18, 7 out of 18, 5 out of 18, and 2 out of 18. You can leave them in decimal points. These are also used as probabilities. They'll ask you what is the probability greater than 8. So you add all these numbers that are greater than 8 here, value of x from this going downwards. I'll explain this as I teach a probability. Then the relative cumulative frequency, 1 out of the last number, 1 out of 18, 4 out of 18, 11 out of 18, 16 out of 18, and 18 out of 18. The last number must be 1. So this is what we call the relative frequency column. Now, how do we find the mean? How do we find the mean? How do we find the mean? So the mean is summation of x, summation of fx over summation of f. Summation of fx over summation of f. So our summation of fx from the total here is 254 over summation of f. So 254 over 18. 254 over 18. So this is 254 by 18, you get 14.11. The variance, you can notice from here that it is the same formula. It's the same formula, except that here we are including f's on each of these ones. So summation of fx minus summation of f to the power 2 over ef. I said summation of f is the same as n divided by summation of f minus 1. So like I said, since you have the totals here, you simply substitute. The variance is simply when square root the standard deviation is simply when square root the variance. So in this case, 28 square root of 28 is 5.3. 5.3. To find the coefficient of variation, who remembers the coefficient of variation? It's simply the same formula, standard deviation over mean times 100. Standard deviation over mean times 100. So 5.3 over 14.11 times 100. So this is how we find our coefficient of variation. Now I'm just interested in the mode and the median because this is something new that you are yet to learn. So how do we find our mode? Like I said, mode is the highest frequency. The highest frequency. So when you go into this diagram here, you need to identify the highest number. What is the highest number in this column? It is 7. That is why you put your FM, 7. So 7, on top of it is F1, below it is F2. So F1 is on top, below it is F2. Then in this line here, where there is FM, you identify the lower bound here, which is 11. Except that the first thing you should have done is the lower bound, the upper bound must be the first lower bound in the next. So upper party 5, there's supposed to be 5 there. Upper party 10, there's supposed to be 10 there. So what we do is we subtract 0.5 on these columns and you add 0.5 on the other columns. So our FM is 7, F1 is 3, F2 is 5. So 7 minus 3 is 4. 7 minus 5 is 2. Then our FM is 7. The lower bound here is 10.5 because we are subtracting 0.5 on each one of these ones. So this is how we find our mode. Fm minus F1 over 2Fm minus F1 minus F2 times the height. So 10.5 plus 7 minus 3, then 2 times 7 minus 3 minus 5, then you multiply times the height. This is important to know. I'll dominate on this in the next class to explain how to find the mode. If you don't get it here, I'll re-explain it again. This is very important. Then to find the median, I said median is a middle value. So you find half of n. So summation of f here was 18. So when you go here, you find half of 18 is what? 9. So you go to the cumulative frequency column, which number is equal to 9 or first exceeds 9. You get 11 there. So you draw an invisible arrow here. So the number above the 11 is your FC. The number next to the 11 is your FM, and you get the lower bound from there. But sometimes, most often or coincidentally, you find yourself that after finding your FM, your F1 is there, your F2 is below there. Then next to the F1 is your FC. That is usually the case. But what I mentioned is the safest. The median is 18. Half of the median is 9. So what is half of 9? What is half of 18 is 9. So you look for a number which is equal to 9, or first exceeds 9. It's 11. So this here, you identify an invisible arrow here. So the number on top of this 11 is called your FC. The number next to the 11 is your FM. Then at the far end, you find your lower bound, which is 10.5, because this is not yet adjusted. So after finding all the values there, you now substitute them in this to get your median. So I'll end here and I'll send you work to do. So if there are any questions, I'll give you the timetable for the next class. I'll be meeting those taking managerial economics next. So have a good evening.